Number 26. What is the ideal speed to take a 100-meter radius curve banked at a 20-degree angle? All right, so down here on the right-hand side, we have our banked formula, right? Oop, that turned into a triangle somehow. So we have our banked formula down here that says that the tangent of the optimal bank angle should be equal to the linear velocity squared divided by the radius of curvature multiplied by the gravitational constant, right? So what are we looking to calculate here? We're looking to calculate V. All right, so why don't we just solve this thing right away for V, and let's see what we get. So simply just do a cross multiplication here. So it becomes tan, well, let me do R radius times G times then tan of theta will equal V squared. And then simply take the square root of both sides. So now we get that the linear velocity will be equal to the square root of the radius multiplied by G multiplied by tan of the bank angle. And look, we now know all the pieces, right? We know the bank angle, that's 20 degrees. We know the radius, it told us 100 meters. They're all in the right units. And G is obviously 9.8. So we just plug everything in and solve. Fairly straightforward here. So the radius is 100, G is 9.8. Tangent of 20 degrees, and then that will equal V. So simply just take out your calculator, square root of 100 times 9.8 times then the tangent of 20, and what do we get? We get a value of 18.9, right? 18.9 meters per second. That will be the optimal speed. That will be the optimal speed that you can take this radius curve on if it is banked at a 20-degree angle. Guys, thanks so much for tuning in. Please remember to subscribe, and I will see you in the next question. Take care.